Hi, this is Alex from devstories.eu. Azure Pipelines, Episode 2 of 10. The difference between a stage and a job dictates exactly where your pipeline will break if you misunderstand agent allocation. Get it wrong, and you might find your build artifacts suddenly missing right when it is time to run your tests. The anatomy of a pipeline, specifically stages, jobs, and steps, is the structure that resolves this. A pipeline is a hierarchical system. This structure strictly enforces how work is divided, where it runs, and in what order. The hierarchy is 3 levels deep. Stages contain jobs, and jobs contain steps. A stage acts as a logical boundary. It groups related work together. In an enterprise application, you use stages to separate major phases of your software delivery cycle. You might define a build stage followed by a separate testing stage. By default, stages run sequentially. One stage must finish completely before the next begins. They act as organizational fences for your overall process. Here is the key insight. Engineers frequently confuse stages and jobs, treating them interchangeably. They do not serve the same purpose. A stage is purely a logical container. A job is a physical execution boundary. A job defines the actual environment where your code runs. Every job is assigned to an agent, which is the machine or container executing your tasks. All operations inside a single job execute on that one specific agent. Because jobs are the unit of execution, they behave differently than stages. If you place 3 jobs inside a single stage, Azure Pipelines will attempt to run those 3 jobs in parallel across 3 different agents, assuming you have the available capacity. This means jobs do not share local file systems or memory. If job A compiles your application code, job B cannot simply access the compiled binaries from the local drive. Job B is running on an entirely different machine. If you need 2 processes to share the same local disk space sequentially, they must be placed inside the same job. Inside a job, you define steps. A step is the smallest building block of a pipeline. It is a concrete instruction, usually a task or a script. Because steps live inside a specific job, they all run sequentially on the exact same agent. Step 1 might be a task to download your source code. Step 2 might be a bash script that runs your compiler. Since they share the same execution environment, Step 2 has immediate direct access to the files Step 1 just downloaded. Apply this to structuring an enterprise pipeline that builds an application, runs unit tests, and packages the result. You create a single stage named continuous integration. Inside this stage, you define 2 separate jobs to speed up execution. Job 1 handles the primary build. Its steps check out the code, run the compiler, and package the binary. Job 2 handles static code analysis and standalone unit testing. Because these are separate jobs within the same stage, they run concurrently on separate agents. They do not block each other, but they also do not share a file system. If Job 2 needs the binary created by Job 1, you must explicitly instruct Job 1 to publish the artifact to pipeline storage and instruct Job 2 to download it. Structure dictates capability in your continuous integration architecture. Use stages to organize your workflow logically, but rely on jobs to control exactly where and how your execution scales across machines. Thanks for hanging out. Hope you picked up something new.